Hi guys, welcome to Bright Math with Mrs. Brown. Today we're finding a derivative of trigonometric functions. Our first trig function is sine. We're going to find the derivative with respect to x of sine u, which equals cosine u times u prime, or cosine u times the derivative of u. What is our u in this case? Here's our example. Well, we have sine y equals sine x squared. Well, what is our u? Our u is x squared. What is our u prime? Our derivative of u is 2x. Now let's plug it in our formula. Our formula says the derivative of sine is cosine of u, which is still x squared, times the derivative of u, or u prime, which is 2x. So usually we can rewrite this as dy dx equals 2x times cosine x squared. All right, all we did was bring the 2x in front of the cosine, and that is our answer. Let's go to the next one. Number 2. The derivative of cosine u is the negative sine of u times u prime. So guess what? Sine and cosine go together. That's how you can remember them. All right? So if y is cosine 2x minus 1, what is our derivative? Well, first, what is our u? This represents our u. And what is our u prime? Our u prime represents 2. So what is dy dx, which means the derivative of y? Dy dx is equal to negative sine of what? Of 2x minus 1 times the derivative of u, or u prime, which is 2. Now, I could put times 2 here, but I'm not timesing it by this, because this is by 2x minus 1, because this is the u. It is the sine of this. This represents the angle, right? So what I do is I bring this 2 to the front. Save some time, and my students love to save paper. Negative 2 sine of 2x minus 1 is the final answer. The derivative of cosine is negative sine of the u, you leave it the same, times the derivative of what is in the parentheses. What is my u? The derivative of 2x is 2, and the derivative of negative 1 is 0, so that's why I only had negative 2. Multiplied it by negative 2. By 2. It was only negative because we had negative sine for our derivative of cosine. All right, here we go. Our next one. Now let's take a look at tangent. I like this one. I thought about this a little deeper because we're not meeting because of what's happening in the world. So the derivative of tangent x is equal to secant squared x. Now notice I didn't put the u in there yet. All right, so how do we actually derive this? The derivative of tangent x. What's another way to write tangent you learned from pre-calculus? Well, it's sine x divided by cosine x. Well, how do we do the derivative of sine divided by cosine x? It's now a quotient, which means I use the, you got it, quotient rule. So my quotient rule said we have u over v. So the quotient rule says bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Low d high minus high d low divided by low squared. All right, so what is our bottom? Our low is cosine. So we write cosine x times the derivative of the top, the derivative of sine, which we know now is cosine x, minus the top, which is sine x, times the derivative of the bottom, which is the derivative of cosine is negative sine. Sorry, it's so tiny. Negative sine x. All divided by the bottom squared. Cosine x squared. Now, I'm going to get rid of this bottom part that we have here. So we can see, well, how in the world are we going to get secant squared out of this, in case you forget what it equals? So what we have left is cosine times cosine is cosine squared x. Minus times a minus is plus, but it's sine times sine, so it's positive sine squared x. I think some of you know what's going to happen already. Divided by cosine squared x. What is cosine squared plus sine squared? It reminds me of an identity from pre-calculus. Sine squared plus cosine squared equals 1. You got it. 1 over cosine squared x. And this 1 over cosine squared x is equal to secant squared x. That's where it comes from. Okay? I've never taught this before, but I believe just knowing where things are derived, it helps you to figure out the answers. So keep that in mind. That's where it comes from in case you forget the formula. So So now let's put our u in there. Okay, so if you're writing these formulas down, the derivative of tangent, having trouble with the top here. Here we go. All right, the derivative of tangent u is equal to secant squared u. All right, so let's do an example. We'll call this example 3. If we have y equals tangent, let's say x to the 5th. All right, what is my u? My u is x to the 5th. What is my du? Or what is my u prime? Oh, sorry, I forgot to put that at the end. U prime. Secant squared u times u prime. What we're actually doing is including the chain rule with our trigonometric functions. All right, we teach it this way so that way I don't have to teach it to you again. We just learned the chain rule. So our u prime is 5x to the 4th. All right, we do the power rule here. 5, bring 5 to the front, x, and then we subtract 1 from 5. 5x to the 4th. So our answer is, this is another way to write derivative, y prime is equal to secant squared u times the derivative of u, which is 5x to the 4th. But again, we're not multiplying it by this u, we're bringing it to the front because it's multiplied by the function of this, okay? So our answer is y prime equals 5x to the 4th times secant squared x to the 5th. Sorry, that's a 2. Getting a little sloppy there. 5x to the 4th times secant squared x to the 5th. So the derivative of tangent u is secant squared u times u prime. And you know how to derive it. Our next one, number 4, is, here we go, at the top. This is u prime. All right. The derivative of cotangent u, similar to the tangent one, it's negative cosecant squared u times u prime. All right, so we see cotangent, we say what? Derivative of cotangent is negative cosecant squared. Negative cosecant squared. So y prime of this one, our equation, our example 4, is y equals cotangent of 3x squared plus 2. What is my u? My u, this whole thing right here is my u. All right, so if I were to write it out, I would write u equals 3x squared plus 2. If I write u prime, the derivative of that is 6x. The derivative of 2 is just 0. So now we have to rewrite it. So our answer is y prime, let's move it over a little bit. Y prime equals, if we have cotangent, the derivative of cotangent is what? Negative cosecant squared of the u, we leave it the same. All right, then we're running out of space, so let's erase this for a second. All right, and what was our u prime? Our u prime was the derivative of this, which was 6x. So how do we rewrite that, everybody? And feel free to pause the video and try these examples on your own. So we have negative here, and we bring the 6x to the front. So it's negative 6x cosecant squared 3x squared plus 2. There we go. That's our final answer. So the derivative of cotangent is negative cosecant squared u times the derivative of the u. We brought the u to the front, boom, u prime. So we brought it to the front, and there it is. Negative secant squared, cosecant squared of the same function, 3x squared plus 2. All right, we're almost done. We have 6 examples. Here's number 5. All right, so our derivative of secant. The derivative of secant u is secant tan. So my students like to say it. Secant u times tangent u times u prime. It looks long, but if you say secant tan, sometimes it's not long. All right? So now, if you see secant, well, our derivative is going to be secant of u, the secant of 4x squared, times the tangent of 4x squared, times the derivative of this u. So if my u is 4x squared, what is u prime, everybody? U prime is 8x. You got it. All right, so if we multiply by 8x, all I have to do is bring that 8x to the front. All right, so let's just move it over and bring it to the front. So y prime equals 8x. Bam, put it to the front and get rid of it off the end. Bam. Okay, so we got secant tan. All right, you leave the u's the same, multiplied by the derivative of the u, 8x. That's the answer right here on the bottom. All right, and our last example, then I'll show you a pattern of how you remember them all. Our last example Let's rewrite this one. There we go. The derivative of cosecant u. The derivative of cosecant u looks like secant almost. Instead of cosecant u, instead of secant, we in secant tan. This one is, I call it co-co. Cosecant cotan. Co-co. Alright, they're both cos. Cosecant and cotan together. So the derivative of cosecant is co-co. Cosecant u times cotangent u times u prime. Alright? Now, we got to do our u first because it looks a little complicated this way. So what is our u? Our u equals 5x to the third. What is our u prime? Or some books will say du. The u prime is equal to, using the power rule here, 15x to the second. Alright, you multiply the 3 times 5, subtract 1, and you get 15x to the second. So y prime equals, the derivative of cosecant is cosecant cotan. So we write cosecant, we leave the u the same, times cotangent, we leave the u the same, times the derivative of the u, which we said is 15x squared. Now, if we don't want to rewrite it, we bring that 15x squared and bring it to the front. So let's just do that for this last example. If you're saving paper, y prime equals 15x squared. Alright, and let's get rid of it on the end. Alright, so there you have it. That's how you find a derivative of cosecant. It's cosecant cotan, leave the u's the same, times the derivative of the u. The derivative of this u goes right here in front. Bam, that's the answer to the derivative of cosecant of 5x squared. So, sorry, 5x to the third. Alright, I get excited about math. Alright, so here you have it. Let's make this look a little bit better for you. Alright, because the boards were together. Here we go. Alright, so that you guys can take a screenshot of it if you want. Here we go. Gotta come a little closer to you. These are all the derivatives. Alright, can you see them all? There you go. The derivative of the trig functions. Number 1 is the derivative of sine equals cosine u times u prime. Number 2, the derivative of cosine is negative sine. Do you notice all the ones that start with c are negative? You guys see the pattern there? The derivative of cosine is negative sine. Derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotan. The ones that are next to each other go together. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tan. The derivative of cosecant is negative cosecant cotan. Co-co. Alright, and remember sine and cosine go together, but if you have a derivative of a c, it has to end in a negative for its derivative. You see the pattern there, guys? If it's a c, cosine, cotangent, cosecant, its derivative is negative. And don't forget the u prime at the end of each one. Alright, thanks for joining us in Bright Math. Bye-bye.